180. Come to 180. If you do this, xy, cosine sine, it's a lot easier. It's in alphabetical order, a lot easier. I do this all the time. I write it down. I'm not a good visual person, so I have to have formulas. I have to write things down. 180. What's the sine of 180? It's the y value, 0. What's the cosine of 180? Negative 1. What's the tangent of 180? 0. 0 divided by negative 1, 0. What's the cosecant? I flip my sign over. Can't have it.
When you say cosine, what do you mean switch x and y?
Reciprocate. Reciprocate it. If it's like this, I reciprocate it. I put the 0 over 1 before so that you would see that that's what we're going to reciprocate. And then it becomes 1 over 0, which we can't do. Or, if you wanted to say it this way, yeah, just put it like if you want to do this, and then reciprocate that, it kind of defeats the purpose, but you can. Or you could say your cotangent is x over y. You can do your cotangent that way, x over y. Just take whatever's here and flip the fraction. Take the reciprocal of the fraction. These are reciprocal functions. Cosine, cosecant, secant, cotangent. They're your reciprocals. Okay, so where are we? Secant is the reciprocal of cosine. Now cosine here is this. So when I take the reciprocal of negative 1 over 1, what do I get? It's the same thing, right? Negative 1. Cotangent is the reciprocal of tangent. If tangent is 0 over 1, and I take its reciprocal, what do I get? Undefined. Do you see a little pattern going on here? A little pattern. Okay? Not really? Kind of? 180 and 360? Now, shouldn't 90 and 270 almost behave the same way? Because the x's are zeros and the y's are numbers? See a little bit of patterns in this? Okay, so let's go through 270. Sorry, I'm still losing my voice here. The sine of 270, my y value, what would that be? Negative 1. What would my cosine be? 0. So negative 1 over 0 is what? Undefined. Can't do it. Isn't that behaving like the 90? Right? This way and this way. Don't they have the same behavior? They have the same zeros in one placements. Cosecant, reciprocal of sine. Take my sine, put it over 1. What's my cosecant? Negative 1. Secant is a reciprocal of cosine. 0 over 1. Take its reciprocal, 1 over 0. Oh, can't do it. And my cotangent. Take my tangent. My tangent of 270. My tangent of 270 is negative 1 over 0. So if I flip that over, I get 0 over negative 1, which is what? 0. See a little pattern? They behave the same because of the placements of x's and y's. I can't divide by 0. You can put any of these in your calculator. Aren't those exact values? Those are exact values. You're going to get a 1, you're going to get a 0. But if you think the quadrant angles and the xy, it goes a little faster and say, well, let me put it in my calculator. I know you guys are kind of calculator driven for this, but I'm trying to get you to think in terms of patterns and circles, because we rotate all these angles around the circle. So 30, we'll do 30, 60. We did the 30 yesterday, right?
Yeah.
And the 60? Did everybody understand those? Okay, so let's do them again. This is the most, and bear with us if you get this, because this is the most important part of your whole trig. So, for a 30-degree angle, I'm going to use Amani's. Can I use yours, or should I use this one? Either one. Okay, so 30 says sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, Tangent, opposite over adjacent. You have to know this. Have to know this. The angle that you're looking at is your reference angle. Side opposite it is the opposite. The leg next to it is the adjacent. The hypotenuse is always the hypotenuse, opposite the right angle. Everybody know this? SOHCAHTOA? Good. All right. Where was that? Sine. So the sine is the opposite over the hypotenuse. In this case, our hypotenuse is 1. So whenever your radius or your hypotenuse is 1, your sine is the same as your y value, or in this case, your opposite. So 1/2 over 1, 1/2. If I looked at this triangle, here's my angle of reference. Opposite over hypotenuse, 1 over 2. If I come to cosine, adjacent over hypotenuse, adjacent over hypotenuse. Tangent, opposite over adjacent, 1/2 over radical 3 over 2. How do I solve these? Can't leave it like a compound fraction, so what do? Keep, change, flip. I change this to a multiply, I flip this guy over. These come out. Okay, if I was here on this one, opposite, 1 over adjacent, 1 over radical 3. Don't I get the same thing? No matter which triangle I use, they're ratios. We call these trig ratios. Ratios reduce to the same thing. All your ratios have to be reduced. You do not have to rationalize your denominators anymore. You have to reduce them. Okay. Cosecant is my reciprocal of sine. So I'm going to take what I had for sine and reciprocate it. So 2 over 1 is good, 2. Secant is the reciprocal of cosine. So I take my cosine and I flip it over. You don't have to rationalize. Tangent and cotangent reciprocals, I take my tangent, I take its reciprocal. Good? All right. Let's use the cofunctions here to do my 60. So what would be 1/2 for 60? The cofunctions. See if you remember your cofunctions. So the sine, the cosine, let's do the sine. The sine of 30 is equal to the what of 60? Cosine. So when I come to cosine, shouldn't this be 1/2? So let me see if that's true. I'm still going to check it. Here's my 60 now. Here's my reference angle. This is now my opposite. Opposite over hypotenuse. Is it radical? Oops, we didn't do that one yet. We did the cosine. Adjacent over hypotenuse. 1/2 over 1. Isn't my cosine 1/2? If I went here, it's kind of hard to see this triangle. Adjacent over hypotenuse. Isn't it 1/2? Let's do the sine. Opposite over hypotenuse. Radical 3 over 2. Do you see these guys? Cofunctions? Just so that you kind of spot. Tangent of 60. Let's do your 60. Tangent, opposite, over adjacent. So we said this is a keep, change, flip. And out comes the 2. And we are radical 3. Good so far? Alright, and all we're going to do is flip these over. Cosecant and sine. And don't rationalize, you don't have to. Secant and cosine. You can see these swap over here. And cotangent and tangent. Good? Now all that's left is the 45. 45, same thing. You could use either angle of reference, it doesn't matter. Sine, opposite, over hypotenuse. Isn't the cosine going to be the exact same because the legs are the same? Right? Tangent, opposite, over adjacent, 1 over 1. 45 is nice. If you want to make it radical 2 over 2, That's fine. It's a habit. I still a lot of times say radical 2 over 2. Cosecant, you're just flipping these guys over. So this is a radical 2 over 1. This is a radical 2 over 1. And flip over 1 over 1. There's your cotangent. You should be able to make this chart by your two triangles and your quadrant angles without picking up your calculator. This chart, keep in front of you. Since you made it, when you work on your trig problems, keep this in front of you. You already figured these out. You don't have to stop again and make a diagram. You have the chart in front of you. Are we good with this? Okay. I want to talk radians for a minute today. Let's talk radians. Let me take this out of here without taking that out. All right. Everybody's ready if I erase this? It should be in the folder over there. Alright. I'll tell you what. Let's not talk let's talk radians. Okay, let's talk radians. You guys remember rotating your angles around your unit circle? And Bram, you used a formula. You did 180 over pi. And pi over 180. So if I took a 30-degree angle, and I wanted to go to radians, and I want the pi, you multiplied it by this. Do you remember why? Because that's what they told you to do, right, Bo? You remember why? Good, because pi and 180 are the exact same. It's pi radians from 0 degrees. Very good. So isn't that the same thing? Pi and 180, isn't that equal to 1? So can I multiply my fraction by 1 and still get the same fraction? Any number by 1 and still get the same number? You have to have a constant here. You can't change anything. So the fact that we know that pi is equal to 180 helps us to get your formula. So therefore, this way, what is 360 in terms of pi? 2 pi. So if Bo told me that halfway around my circle is pi, what is this part? Half of pi. Pi over 2. Isn't that 90? So now watch. I'm in halves. Half pi, 2 halves, 2 over 2. What would this guy be? 3 over 2 pi. I'm going to count by halves. 1 half, 2 over 2. Isn't 2 over 2? Doesn't that reduce to pi? It's just a pattern. Doesn't this then become 4 pi over 2? Doesn't that reduce to 2 pi? Okay. These are just patterns. So if I kept going, if I kept rotating around my circle past 2 pi, if this was 4 pi, well, 4 pi over 2, then what comes? What comes after 4? All I'm doing is counting. Watch. This is 1 pi. This is 0. 0 pi. Okay. 0 pi over 2. Okay. Yep, it is. It reduces. But I'm going to count by halves. I'm going to count by halves. Here's my number line. Here's my number line. I'm going to count by halves. Half. 1. How did you get 1? Oh, 1 half plus 1 half is 1, right? So 1 half plus 1 half is 1. Then what would I call this guy? 1 1/2 or what if I count by halves? 1 half. These are 2 over 2, 3 over 2, 4 over 2, 5 over 2, 6 over 2, right? And they reduce. Same thing around my circle. Same thing around my circle. I'm just looking for patterns. So to help you understand radians, I want you to try to see radians in your head rather than convert all your radians. All these things are patterns. And if you get more familiar with the patterns of this circle, it's less scary. So if I'm counting, this is 1 pi over 2. This is 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2. And now let me reduce this. What is 6 pi over 2? 3 pi. Oh, 1 pi, 2 pi, 3 pi. Agree? I'm just looking for patterns. Eventually you're going to be circulating this circle, especially when you wrap this, more than just one time. When I come here, my halves, 1 half, 2 halves, 3 halves, I can do this. But when I get here, yeah, I'm not going to leave it like that. I'm going to say this is 4 pi. But when I go to graph this, if I have to lay this out, and I have to go to 4 pi, and I have to go every 90 degrees, how am I going to get there? Those are my 1/2 pi's, aren't they? So I'm going to go pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. I'm going to count them all out. I want you to see patterns in this. Don't stop. Keep asking your questions, because it's going to take a little while. So what is a quarter? If this is pi over 2, 90, what is halfway through here? It's a 45-degree angle. So what is half of, okay, so 45, let's do it this way. How'd you get pi over 4? It would be split into 4 parts, okay? So we split 180 into 4 parts. Keep what Lily's thinking. So Lily said 180 divided by 4, 45 degrees. We said pi over 4. Isn't that 4 parts of pi? My half of my circle is pi. So isn't that 4 parts of pi? So stay with me. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Okay, hang in there. Oh, what is 2 pi over 4 reduced to? Pi over 2, isn't that right? Isn't that 90? Aren't 2 45s equal to 90? Okay. 3 pi over 4, oh, 4 pi over 4, doesn't that reduce to pi? So if I asked you, where do I locate 5 pi over 4, what quadrant would you tell me? Third. If I asked you where I locate 7 pi over 4, what quadrant would you tell me? 4, because watch. If I keep counting by 4s, here's the key right here. Here's the other key. Look at this guy. This said 2 over 2, cancels out to pi. This says 4 over 4, cancels out to pi. This says 4 over 2, cancels out to 2. 8 over 4, cancels out to 2. So if you start your circle like this, watch. I want to go by pi over 4 degrees. Pi over 4 radians. So if I'm here, and I'm here, and I'm here, and I say that 180 divided by 4, well, 45 gives me 4, right? So I'm talking pi over 4. This guy's going to say 4 pi over 4. This guy's going to say 8 pi over 4. Is that true? So where am I going to find 3? 1 before 4. It's in this quadrant. Where am I going to find 7? 1 before 8. It's in that quadrant. Where am I going to find 5? I'm rotating around counterclockwise. 1 after 4. I'm in that quadrant. So now when someone tells you, find me an angle 7 pi over 4, you're going to go like this. Oh, over 4? So then this is 4 pi over 4. This is 8 pi over 4. Where do I find 7? Right there. There's my angle. I want you to think in terms of patterns instead of 7 pi over 4. I have to take this. I have to get rid of the pi. I have to multiply by 180. I have to put this in 4 times. I have to do this. I have to get 315. 315 is in quadrant 4. I'll do my triangle. 315 from 360. I have a 45-degree angle. That's a lot to go through, isn't it? I want you to get a better feel for where this circle goes. So can't you find it a lot faster doing that? You'll get used to it. Some of you will catch it like this, and others will say, I don't know what the heck she's talking about. And you can do it your way, but I want you to see patterns in this. All your angles work off of patterns. degrees, and we're going to keep this pattern going right here. Okay, 30 degrees. 30 degrees is what in radians? How many times is 30? Let's use Lily's concept. 180 had 4 of them, right? 4 because she told me it was divided. Each one was divided into half. She had 4. So out of 180, do 180 divided by 30. What do you get? Like 6, right? So isn't this pi over 6? Aren't there 6 sections in this? So 3 sections in here, 3 sections in here. Aren't they every 30 degrees? Well, it's also a 60 degree, but hang on, let's just do 30s for a second. So pi over 6 is what I'm looking for. So watch. Pi over 6 has to reduce to pi. So I'm going to make this 6 pi over 6. All I want you to do is watch, because you'll get the pattern. What should I make this one? 12 pi over 6. Good. So if I ask you now, where do I find 5 pi over 6? What quadrant would you tell me? The second one. And my 30-degree angles are only going to be right here. Because what are these guys up here? 60s. But I can still count them. 1 pi over 3, 2 pi, oops, sorry. Pi over 6, 1 pi over 6, 2 pi over 6. Oh, 2 pi over 6 is the same as pi over 3. There's my 60. 3 pi over 6. 3 pi over 6 is the same as what? Pi over 2. Doesn't 3 90s give me, 3 30s give me a 90? There's my pattern. All I care about are these guys right here, closest to that axis. So when I say 7 pi over 6, where is 7 pi over 6? What quadrant? If this is 6 pi over 6, this is 7 pi over 6. What's my reference angle right here? Pi over 6 is my 30 degrees, right? I know where to find this triangle. Where do I find 11 pi over 6? I come around, I'm 1 short of 12, 4th quadrant. There's my reference angle. You guys put these on circles, right? Come on. Because we know that pi is equal to 180. So how many 30s come in 180? 6. So we take 180 divided by 30. We take 180 divided by 45. That gave us 4. So we take 180 divided by 30, and in a minute we took 180 divided by 90, right? Didn't that give us halves? We started with the 90. We said how many were 90s in here? 4 quadrants, half in 180, so that was half. We took pi, and we said pi over 2. So we're just looking for a pattern here. So now, last one. You're only going to see 30s, 60s, 90s, and 45s. There's no answer. I just want you to locate where you're finding these so that you can convert them in your head without doing the formula. I want you to see where you find them. 60 degrees. So again, how many times does 60 go into 180? 3. 60 is a little different. If I go 60 here and come over 60 here, this little piece is 60, this piece is 60, this piece is 60. So we said 3 times. So isn't this pi over 3? So what would pi be in terms of thirds? 3 pi over 3. What would this one be? So where would I locate 5 pi over 3? What quadrant? My 4th. Because this is 1 pi over 3. This is 2 pi over 3. 3 pi over 3. 4 pi over 3. Whoops, I'm off one. And 5 pi over 3. There's my 5 pi over 3. 1 short. All I care about is this bow tie. No, because a 60 degrees, a 45 cuts it in half. A 60 doesn't. If there's 90 degrees in here, you have 30 left over here, 30 left over here. So, how many times does 60 go into 360? So I should get 6 sections out of here. 1, 2, 3, 4, 5, 6. I should get 6 sections in here. My 60 is the harder one because technically it's not halfway. So if you go 60 degrees, You're only 30 here, 30 here. Then this is 60 right here. Then this is 60 right here. Then this goes 30, 30, and then this goes 60. And this goes 60. They're kind of broken up a little bit. But all you care about is these basic 4. So how many angles can I get with the 60 that I need to do? Pi over 6, 2 pi, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. I'm just going to count by pi over 3s. Make sense? No. Who said no? Reagan? Okay. What part doesn't make sense? Why are we doing all this? Exactly, right? Because if I want, and when we get to this part tomorrow, when we start rotating these around the circle, if I say, give me the cosecant of 7 pi over 4, where are you going for this? What quadrant are you going in? How would you get there? You'd have to convert this to degrees, right? What degrees is this? I don't know. So how would I convert this to degrees? I mean, I know, but how would you know? So degrees, all I know is that 180 is equal to pi. So if I put pi on the bottom now, I can cross this out. 4 goes into here, 45 times 7 is 315. Oh, my angle is 315. So if this is 315, and this is 360, oh, this is a 45-degree triangle. So now I'm going to label my special triangle. 1, 1, radical 2. So now I'm going to find all my parts, and I can find my cosecant, can I? So now, in terms of radians, this is 4 pi over 4. This is 8 pi over 4. If I come around my circle, where has the 7 has to be? Right there. And 4 goes into 180, 45 times. I can bypass doing this. You can do that if you like to, but I want you to be able to rotate these things around. Tomorrow we're going to be rotating your angles around the circle. It's a lot to digest, I realize.
This still works.
I'm more of a pattern person. I like to find patterns because I think in life you get a better understanding when you look for patterns. Look at your charts. We see patterns there. We can find your co-functions. We see a lot of similarities. What numbers are we using? 1, 2, radical 3. Radical 2. You don't have a lot of numbers in there.
Like, if you were to do it like 20 degrees or 70 degrees,
You won't do 20 degrees. We have to do, well, you would?
Yeah.
20 divided by 180?
Yeah, 9.
9, so we pi over 9, pi over 9. So we're only going to do your special triangle.
I'm just doing it.
That's all, yep. And then that would